Welcome guys, I am Yogesh from Professional Training Institute. Today is another class on our practical embedded system. Today we are going to see the diode and transistor PN junction. Can you believe like you are surrounding by the transistors? Means the place you are seeing us on the web. Around you approximately you will have a million or billions of transistors around you. Billions of transistors. In the room which I am talking, I may have a 10 billion transistor around me or more than that. 10 billion, not million, 10 billion transistor around me. Looks fascinated? Yeah, let's see in a class. Hi. So you understand, right, the importance of transistor. Transistors are all around us. All the ICs, microcontrollers, we measure in terms of transistor. They are having a capacity to hold transistor. If you studied in your engineering, we are having LSI, MSI, VLSI, nano chips. Okay. What all these are number of transistors. How many number of transistors they can hold? As much as they can pick number of transistors, that much they will have the higher capacity. Making sense? Okay. So I will not go much detail about PN junction. Did you people study before coming here? Done? Okay, thanks. So I will not go much detail which I am expecting from you people to do. I will mostly try to be sit on the application side. I will test slightly. Okay, so this is a P-type semiconductor. In P-type semiconductor we are having our major hole are majority carriers. And in N-type semiconductor we are having electrons is the majority carrier. Any doubt in this? Very good. So now what we do, we apply a voltage, we apply positive here, we apply negative here. When we apply positive voltage here, what will happen? It start repelling them. It start repelling the hole. So when we start repelling the hole, these holes move towards this direction. At the same time, this electron is opposed by this negative charge, they start moving in this direction. Okay? So ultimately, all electrons are moving in this direction and all holes are moving in this direction. In the normal language, normally we say the current is a opposite of flow of electron. Okay, so my electrons are flowing in this direction. So my one current will establish in this direction. This condition we called as a forward bias of diode. This condition we called as a forward bias. Okay. We are having another condition. Consider this is another PN junction. It is also having holes and it is having electrons. Apart from holes, he is also having a minority carriers. Minority carrier means less number of electrons he is also having. Electrons. Mainly he is having hole, but he is having electron also. Same way here also, he is also having some holes also. They are the minority carriers. Very less in number, but they still exist. Okay. So now consider what we do if we apply a negative voltage here and positive here. So here we apply the negative voltage and here we apply the positive voltage. What will happen? Yeah, how depletion region will form? How depletion region will form?
Holes are attracted to negative charge.
Sorry?
Holes are going this side, sir.
Can you tell how depletion region will form?
Holes are attracted to the negative charge.
Holes are attracting towards the negative charge, okay?
Less electron are going.
And electrons are attracting towards this, okay?
Little electron from the p side.
Electron from p side.
Is little.
Yeah, electron from p side will start moving, repelling, and it will come till here. At the same time, hole from this will start repelling here, and they will fuse. They start fusing here. You understand? When they come here, they will start fusing. After a certain period of time, they will have a huge, they will have little bigger region, and they will form little bigger region of fuse. Fuse means they mix hole and electron, and after that, this becomes the depletion region. You can study much more if you want. There is many things to discuss in depletion region. Even like we can spend a 1 day, 2 day in the depletion region itself. There is huge to discuss. But in application side, it's okay. We can this much knowledge is fine. So it creates one depletion region. Due to that, there is no current will flow. Because after that, if any electron is coming, it's very difficult for him to cross here. Making sense? Any doubt? Any doubt?
Why is there no current in this?
Why there is no current? Reason being, there is no path is established. Until unless we are having one short circuit path established, current will not flow. In this region, we are not allowing anybody to cross this region from here to here. Okay? Like consider a river is flowing. River is flowing. What we put? We put one stone. Then we put another stone. Then we put another stone. Slowly, we completely blocking the path. We completely block the path of river. You understand? Then this water will not flow because we stop. Same thing is happening here. We slowly building here depletion region, and at certain period of time the depletion region is so strong, the electron is not having capability to cross this, and holes does not have capability to cross this. They becoming as an open circuit. Understand? So that's why current is not flowing. Had you seen diode earlier? Not seen? Yes or no? Okay, you have to say now, then I will bring and show. You seen diode? See, this is the diode, if anybody not seen. This is my student are doing some practical, so I bring from there. Able to see? This all are diodes. They are making power supply. So, understand? Any doubt? Seen diode? Okay. Any doubt? Okay. So the diode, it's having a ring. Okay, if you see the diode, it's having a ring here. Okay, so it shows the direction. One is plus, one is minus. Okay. Fine. So this is forward bias, this is reverse bias. Any doubt in this? Then can you tell what is the use of diode? What is the use of diode?
Control the current.
We make diode like this. What is the use of diode? Regulate.
To protect the circuit from damage.
Yes, to protect circuit from damage. How?
By putting some current.
How?
Protecting the current.
How?
Reduce the overload of current.
How? It cannot protect current. It cannot reduce current. That work is given to resistance. Diode is blocking current in one direction and it's allowing current in one direction. This property you can use. Making sense? Diode is working in one direction like this pen. Pen work only from this direction. It won't work in this direction. Okay? So if you want to write here, you can write it. Okay? But if you don't want to write, you cannot write it. You have to. No, I am not joking. This is very serious analogy. I am not joking. This is the diode. This is the diode. Okay? In this direction, if you write like this, it will work. If you write like this, it won't work. Okay? So if I want to protect, I don't want you to allow write, I will give you pen to like this. So you cannot write anything here. Making sense? But if I want to allow you to write, I will give you pen in this way so that you can write. This is the diode. What is the advantage? I am stopping unwanted write on my board. You understand? You cannot change. See, you will say, sir, if you give me like this, I will turn like this. You are having mind. Electronic circuit does not have mind. You understand? Electronic circuit does not have mind. Whatever way we connect, it will stay in same. Making sense? Whatever way we connect, it stay in same way. It won't change himself. Understand? Okay. So, if you say it used to protect from current or overcurrent, this is the method. We connect the diode such a way, if any unwanted current coming from this side, that will be protected. I will give you one example. Consider we make one electronic circuit and this is our load. Okay? And in our load, had you seen any electronic circuit? Which one? Consider this modem. Consider this modem, this is the modem, okay? Or Wi-Fi router. This is the Wi-Fi router. In the Wi-Fi router, what we done? We are having LAN cable, right? LAN cable is output or input? It's both. If we are sending data also, we are receiving data also. Making sense? So we are sending data also, we are receiving data also. But all those data is in maybe in 5 volt range, plus minus 5 volt. How much? LAN cable voltage level.
No idea.
Yeah, I am saying it may be in 5 volt range. I also don't know, but it will be in 5 volt range, plus minus 5 volt. It will be less than that. Okay? But if I give 20 volt from there, what will happen to circuit? You understand what I am saying? That code he not made for 20 volt, right? He made for 5 volt. What he will do, what he already done or he will do, what he will do, he will put one diode inside. You understand? So when your voltage is exceeding from certain level, this diode is become open. Making sense? That can be one kind of example. Means this example also having a some flaws. I understand that. But just for analogy, this is fine. Making sense? What I am saying? What is use of diode?
When some unwanted or excess amount of current is flowing
open circuit, if we connect in this direction, at the same time if we connect in this direction, then what will happen? If by mistake we connect in this direction, then what will happen?
Increasing voltage. Same.
What same?
Not same. Different types is
Hmm?
short circuit.
When we have high output here, it will go inside. But if from inside some voltage is coming, he will block. You understand? If from inside, if we are having some high voltage coming, he will block that. And that is the 0.7 volt only. Diode forward, diode reverse depletion region is 0.7 volt. Making sense? Okay, fine. So this is one of the use case where you may not able to clearly understand what I am saying, but this is one kind of use where if you want to flow only one direction current, then we use this diode. Okay. Another use case of diode. Okay. One more use case of this is consider we are having a input. We are giving AC input cycle like that. And if this AC input, if we give to diode, what will happen?
It will be half cycle.
Why?
Positive cycle.
Why?
It's largely in reverse direction.
What do you say?
Diode will act as a forward bias and reverse bias, forward bias, reverse bias.
Yeah. So what will happen when it behave as a forward bias then? Consider it is forward bias. What output I will get?
Only positive.
This I will get. What I will get for negative? No. And again positive like this. Again negative like this. Okay. So I had given this type of input and I got this kind of output. Okay. So is this a DC? Is this a DC? What it is? What type of signal? This is AC or DC? AC. Very good. So this is a AC or DC? DC. You know what is DC? What is DC? Yeah. How to draw direct current? How to make direct current? Straight line. So this is a AC or DC? AC. So this is AC or DC? So this is also AC, this is also AC.
Rectifier means it's converted AC to DC.
No, I am asking different thing. Don't tell me Amitabh Bachchan is son of Abhishek Bachchan. I am asking this is AC, right? This is DC or AC?
AC.
AC. And this is also AC. This is also AC. No, this is not AC. This is not alternating. AC must have alternating. Alternating means it should go negative in another direction also. So it's not a pure DC also. It's not a pure DC. It's a pulsating pulse. It's half wave pulse, half wave rectified pulse. Okay. You have to make it DC. It's not yet DC. Making sense? Okay. So how to make it DC? This process is called as rectification. This process is called as rectification. Consider we had given input here. What is the voltage level in our home we are getting? In home, what voltage we are getting? 230 volt. 220 volt. Had you measured any time in your life?
Yes, but we get only about 200 or 180.
Yeah, you measured voltage any time.
Sometimes in the inverters.
You measure voltage. How you measure? Through hand.
No,
If you put hand, it will tell, I have 220, 320, like that, or How you measure the voltage?
Just indicator in the inverter.
Oh, through indicator. Very good. Go and bring multimeter. Through head they are measuring. They touch the head. If shock is less, then 2 count. Shock is more, then it's 3 count.
Home supply 230 volts.
230. I'm just asking. Did you measure sometime? Measure. Yeah, you should measure. Being as an electronics engineer, you should be aware of this thing. Should not be like, yeah. Measure AC here. Come. This is the live demonstration how to measure AC. Come, my friend. Come on the camera. Yeah. I'll help you. Yes. Put it there. Oh, you see there, na? It will shock me also. Okay. Okay. Yeah, so this is AC, okay? What is the frequency of this?
Yes.
Call everyone from there. Call everyone. Everyone, sir. Come 1 minute. Just 1 second. Hey, come stand just 2 minutes. Hold on this. We people not seen the how much input frequency we are getting in our home. 50 hertz. Okay, all know, right? We are measuring. So we are having here hertz. So we are having here hertz measurement frequency. So I click on that. So it went in hertz mode, and then I am. It's 49.96 hertz. Okay. What's meaning of this? What is meaning of this? Yeah. What is frequency?
1 second.
1 cycle.
1
1 second.
But also
Very good, very good. In 1 second, this many cycles are coming. Okay? Yeah, that's all. Thanks for coming. We not done this, that's why I got. Take this. Yeah, okay. So we are having 50 cycles in 1 second, and that's why it is 50 hertz. What is hertz? Of what is frequency?
Which is how
What is frequency?
This is equal to 1 by T. This how many period? How many cycles?
Frequency is number of cycles in 1 second. Number of cycles in 1 second.
1 second and no period.
1 second.
Period means
No.
one complete cycle.
Eh?
This is one complete cycle.
Yeah, this is one complete cycle. Like this, how many cycle in 1 second? Yeah. So that is 50 is frequency. Okay, so this frequency, what I did, I had given to diode. So when I given to diode, he is giving me pulse output like this. So this is the pulsating output, neither DC nor AC. But if I want to use as a DC, I will get some average value of that somewhere here. So that I can use. Making sense what I said?
how to get the download.
Yeah, there is some formula, I do not remember. I2 IM by something root 2 or something like that, one formula is there. Through that you can calculate. There is some derivation also in our first sem of engineering, we do this thing. Okay. You have a look. If you have doubt, I will help you. Okay, but this is not my desired output. What I want, I will put one more diode here in this direction. So for positive cycle he will work, for negative cycle he will work. So for positive cycle he will conduct, for negative cycle he will conduct. Sanjoy, any doubt? Sure. You studied this? When?
In the first class.
Why you not studied yesterday?
I studied
PN junction. Okay, no problem. Fine. Digester will come. First, let me finish the diode. Okay, so we got this kind of pulse. Is this pulse a DC? Is not pure DC, but its average will be little more than this. Little more than this pulse. Okay, it will be little higher. Now what to do? Consider we are having this type of output. Then what we do? This type of pulse, we start doing the filtering. We start doing the filtering. Okay. In the last class we seen the capacitor. Okay. So in this class, this is our diode circuit, and in the diode circuit, after a regulator, we will put one capacitor. This is the electrolytic capacitor. This is the electrolytic capacitor, and what we do? What this electrolytic capacitor do? When you are giving input till here, this capacitor will start charging himself. The capacitor start charging. When you give this charging. Okay. So the output we will get charging till here. Ask question. Don't wait for tomorrow. You will ask. Ask now to me. Any question? What I am talking? What I am talking?
When output is coming out, the capacitor is also charged.
Yeah, why I put capacitor here?
To filter.
To filter. Why I want to filter?
You want output because
Output is already there, no? This is output.
DC output.
We want good pure DC output. Okay. So for that, when we give input cycle, this capacitor is charging. Okay. Charging here. After some time, this cycle goes downward. When this cycle goes downward, he also try to go downward. But when he start going down, capacitor is asking, hey, why you are going down? Capacitor asks to him, why you are going down? Then he say, I don't have input voltage. Input voltage is it's going downward. Then capacitor say, hey, don't worry, I am here. I will give you voltage. Okay. Then this capacitor starts supplying voltage. Oh, I'm sorry, it's not working. This capacitor starts supplying the voltage. Making sense? After this, he start again giving the voltage. He start gaining the voltage. But when he start gaining the voltage, capacitor says, I will also charge. Okay, so he also start charging. Making sense? So We are getting, earlier our pulse was like that, now our output is like this. Making sense? Is this improved? Is this a DC?
Partially DC.
Partially DC. We are improving. We are from here, we improved lot. And if our capacitor is having good strength, it's able to hold my full voltage here, then we can get the full DC. You understand? Why this pulse is going down? Because my capacitor does not have power to give. If my capacitor having power to give, then it don't select, pay attention. You have to make, you know why we are reading this? After this class, maybe tomorrow, after tomorrow class, you have to do experiment. You have to make power circuit. You have to do all those register operations. Practically you have to do. And you have to do alone. If you sleep now, you will struggle that time. And this week you have to finish, because Monday onwards we will start new course. Digital electronics we will start. Okay? Yeah, so if our capacitor is more powerful, then this won't go downward. It will be hold here and we will get it. Making sense? Any question? Guruji? Okay. Understand? So here we cover two things. We cover diode. What is this? Where is diode? This is bridge, okay? This is bridge rectifier. This is capacitor. So we cover two things, diode as well as capacitor, okay? So we seen the application of diode. Now, most important part, that is transistor, our loving transistor. Had you seen transistor? No? Go and ask them, give me transistor. And whatever your communication, you come and tell here. We will show you the practical transistor if you not seen. If seen, please wait for us. I also seen, but you have to wait. Every one of you has to learn. Correct, right? Whoever sitting has to learn. Wow. Show to camera. Little away. Just to focus. Okay. So this, see it. Then return. So what is transistor? Transistor is having a NPN transistor is having NPN and it is having a three semiconductor materials which is different type. They are cascaded in a some specific manner and yeah. So in this we are having a one emitter, collector and base. What is emitter? What is collector? Any doubt or any question? Or don't know? But you studied, right? You studied in home. Consider this is emitter, this is base, this is collector. It is a three material you can say. What is use of all of them we are going to see in sequence classes. Now what I am doing, I am basically transistor is a magical device, and you know what is the magic here is? Magic is, I will say, shake your hand, remove, shake your hand, remove, shake your hand, remove. This is the magic. This is is the magic. Means I am, which is not you, but I am able to connect you people. You understand? We three are same. We three are sitting in a one group. We three are sitting in one group. But when I say shake, you are shaking your hand. When I say remove, you are removing your hand. How powerful I am. You understand? Don't see you as a yourself. Consider from you are having some 100 people are standing here. 100 people are standing here. Or consider the current is flowing from this direction. Current is flowing from this direction. And I will say shake hand. So that current can start going either here or here. Making sense? Consider you are at ground level and that high current is coming. But it will come here and stop. It won't go ahead until I give permission. Feeling magic? Yes or no?
Yes, sir.
Yeah.
How we connect, sir?
Yeah, that I will tell. That I will tell how you connect. But are you feeling this is amazing? Are you feeling this is amazing? Whole world is running on this concept currently. Whole world. Because I get input from somebody else. Consider my God told me something. I got input. That input I am giving to you. You done something. When you connected, this side another transistor, this side another transistor. They also start working. They also stop working. They stop working. They start working. Making sense? Only I had given one signal. Based on that, so many things is happening. Making sense? Yes sir, yes or no? Yes, sir. Okay. How it works is, I don't want to go inside like how transistor works and what all that. That is not my cup of tea. But if you have any doubt, I am available. I spent approximately 1.5 months in a PN junction, PN diode, diode transistor, transistor theory, transistor biasing, all those things I spent huge time. I studied from many books. So any doubt if you have, I will take it up. In this class we are limiting here. Okay? You can come up and ask me any question. Now consider, I am giving here, this is negative, right? So I am giving like this. What will happen, Sanjoy? What will happen to this junction?
Negative to B and positive to N.
Yeah, then what is meaning of this?
How is that possible?
How this is possible? It is possible, no? I had already made possible.
But you write positive in there, sir. Positive in the positive.
This is battery, sir.
Where?
Forward bias.
Forward bias. Who is forward bias?
N and P.
N and P. They become forward bias, right? In which direction current will flow?
Positive P to N.
Current will always flow from positive to negative, like this. Okay? So they will become short and the one current will start flowing. Okay? Any doubt in this? When I say they are conducting, they two are conducting, right? Earlier they was different. Earlier they two were different. Okay? Earlier they two are different. When I made them forward bias, they start conducting. Can I say they become short? Can I say they become short? Can I say this ammeter is connected to collector? but they are short.
Yes, sir.
Enjoy.
Yes, sir.
They become short. This emitter, earlier it was connected to base. Now when they become short, can I say, don't select, pay attention. When they become short, this emitter is connected to collector. Can I say like this?
Because
He is saying no. Can you slap him one time?
they become one.
They become one.
Elements one.
They become short now. They become one. They become one. You are two, right? You are two, and he is connected with this chair. But if you become one, then are you connected with this chair or not? You diffused completely. You emitter here, this one. And when they become forward bias means this will be plus and this will be minus like this. Okay? That time the emitter is connected to collector. Where it is? In this diagram, can you tell me? Collector is connected to the emitter like this. Sure? It should be. Very good. So this is and this is same now. And this is the magic. This is the third terminal. You have transistor, right? So it is having a one terminal. You can consider center terminal. So through center terminal, you are able to control these two terminals, whether they has to connect or not connect. Making sense? It is important. Understand? Any doubt? So through base terminal, I am able to control the emitter and collector whether they are short or not short. Making sense? Okay, let's move ahead. Okay, now do some biasing. I will do some biasing. This is 5 volt. It may be 10 kilo ohm transistor, ground. Here 500 ohm, 5 volt and ground. And I am taking output here. Yeah, so this is 5 volt and I am giving through 500 ohm I am giving to base. 500 ohm I am giving to base, and on the collector we are giving 5 volt biasing with the 10 kilo ohm resistance. Okay, so when I do 10 kilo ohm resistance, and this is my output. Okay, so what output I will get? What output I will get? Can you people think and tell? In this circuit I had done the biasing. I had given 5 volt here and 5 volt on the collector region. Tell me the output. You understand my question? So enjoy. You understand question? What is the question?
To find output.
To find the output in this condition. Okay, do it. What is this junction?
P.
Yeah, P. What you connected? So what will happen to this junction? Is forward bias or reverse bias? Forward bias. So this will become short. Okay. So when this becomes short, can I say this emitter is connected to collector? Yes or no? So this emitter is connected to collector. So what output I will get? Same as emitter. So what is emitter? 0. So I will get 0. What he said is correct. So we don't need to remember I done in my first sem like this, I did in second sem. I am doing here in front of you. No need to see, everything is in front of you. So when we given 5 volt, we got 0 output. When we given 5 volt, we got 0 output. Okay. Now give here 0 zero input. When we give zero input, what will happen to this junction? It will be forward bias or reverse bias or any other bias. If I give 0 volt here, what will happen to this junction? Open circuit. What do you say?
Zero means that no voltage.
No voltage.
Reverse bias, open circuit.
Yeah, it may not be reverse bias, but it will not conduct. It will not conduct. So I can say if it is not conducting, then open. If it is not conducting, then it's open. If it's conducting, then it's connected. Making sense? So this is open. Okay. So can I make open? When they are open, is the emitter is connected to collector? No? Sure? So if emitter is not connected to collector, so can I say it is open here also? In the collector and base junction? Collector and base junction are connected. I know this thing. Okay, but they are not conducting anything. They are not conducting anything because this junction is open. Okay? And this is also open. So this path completely is in open. This path is also in open. Both path is in open system. So any current will flow? No. So when I give input 0, what output I will get?
5 volt.
5 volt. What do you say? Why?
Because there is no path.
There is no path. We will get output like this. Okay? Any doubt in this? No. So you see what magic here? We given 5 volt, we got 0. We given 0 volt, we got 5 volt. Making sense? This is the transistor as an inverter. Transistor is behaving as an inverter. This is the property of transistor. Transistor is behaving as an inverter. Making sense? Yes or no? Note down this thing in your words. Sir, any doubt? No doubt. Or more doubt? No doubt. Fine. Done, friends. So this is the transistor. Transistor is a switch.
Switch was same as inverter.
Sorry?
Switch is same as inverter.
Yeah. This is switch, no? I'm turning on and off. Don't see input. But I'm making on and off, right? Output. I'm saying connect, so you will connect. When I'll say remove, you will remove. Understand? Any doubt? No. But
What is the definition of transistor?
sorry, definition of transistor.
I'm not sure, it will be confusing.
This is fine, right? You note it down. I am realizing it. Transistor definition, I don't know, maybe these 3 layers are connected due to that.
I'm not sure, transistor is amplified signal or direct, it acts like the electrical signal.
No, both. I am not talking about the transistor as an amplifier, because we are having other method available to amplify the signal. We are having op-amp, through that we can amplify the signal. Although the op-amp is also like made up with the transistor. Okay, we will see. We'll start. We'll move one more time. We'll move one more time. One more time means we'll move one step ahead now. And we will see the flip-flops. Or instead of flip-flop, what I will say, consider this is the 5 volt. Consider I am taking output here. If I give 0 input here and 1 input here, first I will give 0 0. What output I will get? 0 0. What is my output? Will this work? No. Work means, will this forward bias or reverse bias? Yeah, you will say. Forward. Why? What I given here? What I given here? What is input?
1 volt.
Yeah, that's why I answer. It is not 1 when it is 0. I wrote 1, then I made it 0 because I thought I will give 0. I understand when he said 1. Because he understands clearly. He is having clear idea. I can see the way he is speaking. Once you understand clearly, you cannot make mistake. You not understand yet. You are still in the some. You are able to solve. I am not saying you are not able to solve. You will solve, but still you have some doubt. Do you have any question? No, right? Okay. So if I give 0, then what? Will this transistor work? No. Will this transistor work? No. So what output I will get here? 5 volt. I could say 1 here. Now I am giving 0 1. What output I will get?
1 sir. 0 1.
I will get 0. Okay? Because this ground will go here, this ground will go here. I will get ground here. So which gate it is?
And gate.
NAND gate. Okay? So this become NAND gate. Okay? And you know that when we make flip flop, then through NAND gate we can make the flip flop. You know this thing? So in one NAND gate, how many transistor? In one NAND gate, how many transistor? In front of you, what is that? No. Everything here. In one NAND gate, how many transistor? In this NAND gate, how many transistor? 2. You know this become flip flop, and what is use of flip flop? To store data. Store data. Yes or no? You don't know? Eh? Okay. Flip flop is a basic memory element. Flip flop is a basic memory element. It used to store data. Okay. Flip flop, how it works, we will see in the next class or some other class. But flip flop is used for the storing the basic memory element. And what? How many bit it save? It save 1 bit. How many bit? 1 bit. In 1 byte. In 1 byte. How many bit? 8 bit. Understand? So how many flip flop I needed for 1 bit? 1 byte. For 1 byte, how many flip flop needed? In 1 flip flop, how many bits I can save? See, if you sleep, you will not able to answer. You have to open your eyes and understand. In 1 byte, how many flip flop needed to save 1 byte?
system, sir, that is one. That is one meter, right, sir?
This is one flip flop.
Okay, one.
This is one flip flop.
This cover is one meter,
One bit.
One bit.
So for one byte, how many flip flop we needed? 8? 8 flip flop. In 8 flip flop, how many transistor total? In one byte, how many transistor? 16 transistor. Okay? Any doubt? Fine. So, see this, I am having a 16 GB of pen drive. 16 GB of pen drive. Okay. Can you find out how many transistor it is having? You understand question? Any doubt you are having in this? Talk to me first, then calculate.
1,31,000 transistor.
No, how you calculate it?
16 GB, sir. Is divided into 1 MB. So into 1 MB, sir. 1024 MB.
Okay, then?
Then I answer it to 8. So 1 bit byte is equal to 1 bit, 8 bits. Converting GB into megabytes, sir.
Then
Into 8.
Then it come in megabit, right?
Megabytes.
Yeah, your answer is wrong. So I am having a 16 GB hard disk. 16, I'll write there. 16 GB. Not hard disk, 16 GB of pen drive I am having. So 16 into 1024. This many MB. 16 into 1024 into 1024. This many kilobyte. Then you have to find the byte. And then in the byte you have to find the bit. Okay. And in the each bit you will have flip flop. So I want to know in my 16 GB pen drive how many transistors are there. In my 16 GB pen drive how many transistors are there if they are using NAND gate. Making sense? Calculate. Any doubt you ask to me? Any doubt you have? Do it. Any question? How many transistors?
2, 1, 4, 7, 4, 8, 2,
Yeah, tell me 2,
1, 4,
2, 1, 4,
7, 4,
7, 4,
8, 3, 6,
8, 3, 6,
4,
4, 8. This many transistor in my pen drive. Only in pen drive. I am having 1 terabyte of hard disk in my bag. 1 terabyte. My laptop having 500 GB of hard disk. It's not only hard disk. My processor is i7.
Pendrive is this size, sir. Pendrive is this size. 8 GB, 13 GB. How it is possible?
It is possible. It is there. It is there.
Then the answer is about this time.
Yeah. This is one transistor. And like this, in this drive, this many transistors. That is VLSI. Very large scale integration. Now we are talking nanotechnology. Nanotechnology will reduce 1 upon 1000. You understand meaning of that? This pen drive is this big. 1 by 1000 it will reduce. Means this big. Maybe lesser than this. This many transistor will pack into that size. Your 116 GB hard disk will be of that size. Making sense? So we are surrounding by the transistor. So you should respect transistor. You should not sleep when I am teaching transistor. But
those transistors are so small, and we cannot see with our naked eye, but how it can connect?
They works properly. That's why like all my, when I save your photo, when I open it not becoming his photo. If I save your photo in my pen drive, when I open in computer it not becoming Manu photo, right? It is your photo only. So it means the transistors are working properly. And in this pen drive we will have more than this transistor. It's not only this. This is the memory element. This is the memory element. It will have the processor also. You understand? It will have the processor also, USB controller also. He will have many other things. This is just memory element. But it will have processor also, it will have memory element also, means USB communication also, all those USB sticks also. So all those things is separate. Making sense? Feeling excited? Okay, nice. Yeah, after transistor, yeah, we done the power supply, we done the transistor, 555 and 761 and resistor. Yeah. So now we are concluding your basic electronics, and you have to do now experiment. But the main part here is you have to finish your experiment in next 2 days. Monday on Saturday you will be busy because we will have presentation and maybe one of the senior vice president of one of the companies visiting us. Okay, so he is having a big company here in Bangalore. He is working in telematics and navigation system. So he may be visiting us, so Saturday you may not get time. Today is Wednesday. So today you don't go home just after this. You do the experiment. I am saying what you have to do. Finish experiment today, tomorrow and Friday. In 2.5 days you have to finish your experiment. Monday onwards you will merge into that batch and you will have digital electronics. We will start from there.
Digital electronics.
Nothing theory. What are we talking? Anything theory? Is this class you are feeling theory or what? See, I have to write somewhere, right? How do I transfer my message to you? Now tell me, if you are feeling theory, I have to change many things. I am trying to make everything you should able to visualize. Okay, I am able to show you inside the pen drive. Amazing. How can I drop my pen drive and show see inside? It's costly device. But I can show you, hey, my transistor having, my pen drive having this. Now you are able to realize, oh, like that, This is different. No, tell me. So it will be not be theory, you will be keep doing the thing. You will be keep doing the thing. Of course, like somebody is there to tell what to do, so that I will do. Okay, so what all you have to do in this 2.5 days? That resistor combinations, series, parallel. Okay, you have to find the current, you have to find the voltage. Power, we are not having power meter, but you can find the voltage and current in the circuit. Understand? After resistor, you can do the diode experiment, you can do the transistor experiment, you can make power supply, and you have to use the 555 timer. You know what is 555 timer? You know 555 timer? You will get to know. Okay. This 555 timer is used to generating the output pulse like this. So you can generate different type of pulse. 1 kilohertz, 2 kilohertz, 50% duty cycle. You know duty cycle? Duty cycle means if this and this are equal, then it means it's a 50% duty cycle. Duty cycle is 50%. But if this is a like this, so this is only 10% on, 90% off, then this is called 10% duty cycle. Understanding? This is duty cycle. How much time it is on? What I am talking?
Then it is 50% duty cycle.
Correct.
Then duty cycle is calculated in
On time. This is on time. Okay. So this is, consider how much time there is one formula for that. Consider this is a T on and this is T off. So T on upon T on plus T off. I don't want to tell this formula, okay? I don't want to tell this formula. But just for your asking, so that's why I am doing. So in this only 10% it is turned on. How to make 90% on? How to make 90% duty cycle pulse here? Can you help me? How to make 90% on? Tell me. Tell? Then 90% duty cycle.
Decreasing T off.
Now what I have to do?
then the option will be 10%.
Yeah, like this. Okay. So this is 90% duty cycle. Understand? So in using 555 timer you can generate different pulse. They will help you. Okay. And one more you can do the 7 segment. Have you seen the 7 segment earlier? 7 segment display? Where you see? Okay. Practically you not seen. Practically, okay. It is. I will show you outside. So it is a 7 segment like this. It is like this. In this 7 segment you can display 1. If you turn on this it will become 1. If you turn on this it will become 2. Like this you can make 3, 4, 5 like that you can make. Number, you can make A, B, C, D, A to Z. Anything you can do it here. Making sense? Do all this experiment. Apart from that 2 more experiments are there that they are having. Okay. You finish all. Okay. In 2.5 days. So next 2.5 days no class, means I will be there but they will help you. They are already doing. So what all you have to do? Series resistance, parallel resistance, voltage, current, all those things you have to do. Making sense? Start from today because you people have less time.
What about the direction? What we have to do in that?
Sorry?
What we have to do in that?
Check whether whatever I said in forward bias is working or not, in reverse bias is working or not. Check one time. We are having CRO. Just today only we brought our CRO. So use help of CRO. I will also work in that case with you. For them also I will show. Okay, fine.
Then about class.
They will tell. Transistor you check as a switch. You give 5 volt, check output 0 is coming or not. You give 0, you check 5 volt coming or not. Understand? Whatever we learn, that you have to check. Power supply, you know, you have to make 5 volt power supply. 5 volt power supply. So every component I will give, you have to just make it. You have to do soldering and other part, and you have to do it. Then 555 timer. This is the IC. Listen me. This is the IC which is used to generate the pulse, output pulse. Okay. So you have to generate 2 pulse, which I had given them. I think 1 kilohertz 50% duty cycle and 2 kilohertz 80% duty cycle. Something like that I had given them. So same question you also do. 7 segment you display from A to Z and 1 to 10, 1 to 0 on the 7 segment. A to Z, A, B, C, D, everything has to come there. Making sense? You people have very less time. 2.5 days is not more. Do it. Start it today onwards. Don't go home. Don't be in hurry. Spend more and more time. Okay? Rest of luck. Thanks guys. Thanks for watching me. Stay tuned. Next session we will have on Monday. Coming Monday. So let's meet on Monday. Okay. Bye. Have a great day.